This video lesson is about solving systems of equations by elimination. And for elimination, really the ideal setup is that our x term is right on top of each other, and our y terms are right on top of each other, and then our constants are right on top of each other. If they're not, we're going to have to work that problem to get it into the form. So for example, if we had negative 2y is equal to 4x minus 12, instead of what we were given, we would have to subtract the 4x from both sides and then get it to look like we have it. So we always want our x term first, then our y, then our constants. If I were to add these equations together, this negative 4x and this positive 4x would eliminate because that would equal 0. These are zero pair, they're opposites. So if I add the y's together as well, negative 2y plus 8y is 6y. And negative 12 plus negative 24 is negative 36. Dividing both sides by 6 gives me that y is equal to negative 6. Just like in graphing and substitution, I am looking for an ordered pair that is my solution. So I know the y value is negative 6, and then I'm going to go back and find my x. So I can pick either equation. I'm going to pick the bottom one just because there's no negatives. So I have 4x plus 8y is equal to negative 24. 4x minus 48 is equal to negative 24. I'm going to add 48 to both sides. 4x is equal to 24. Divide by 4, and x is positive 6. Just like in all the other problems that I've done, I'm going to check my work. So I'm going to make sure that positive 6 for x and negative 6 for y satisfies both of these equations. So negative 4 times 6 minus 2 times negative 6 should be equal to negative 12. That's negative 24, that's positive 12, and yes, that is true. All right, second one. It looks like I can easily eliminate my y's here because I have negative y and positive y, and those are also a zero pair. Those are opposites. Those are going to eliminate when I add together. So x plus 2x gives me 3x, and 11 plus 19 gives me 30. Dividing both sides by 3 tells me that x is equal to 10. So I have my x value this time. I'm going to go back and solve for my y. That's a pretty easy problem. So either one is going to work. X minus y equals 11. I'm going to subtract 10 from both sides. Negative y equals 1, so y is negative 1. Let's check that out in the other equation. 2 times x plus y should equal 19. 20 plus negative 1 is 19. It sure is. There's my solution. So again, if I were to graph these lines, I would find that they would intersect or cross at the point 10, negative 1. So now we get to the dilemma of what do we do when we don't have that setup where they just easily cancel out? If I were to add these together, I would get 5x plus 2y equals negative 21. And that didn't eliminate anything. So what I have to do is pick which variable I think would be easier to eliminate. So if I were to take this second equation, or the first one, it actually doesn't matter, and multiply it by negative 1, I will have successfully canceled out my y's. So I'm going to leave this top equation how it is, and I'm going to distribute a negative 1 to this entire equation. So that changes me to a positive 3x, a negative y, and a positive 5. Now when I add, those x's eliminate, and I have 11x is equal to, that's negative 16 plus 5, so that's negative 11. And when I divide, I get negative 1. That's my x value. Now I have to go back and find my y. Just like in the last time, I can pick whichever equation I think is easier to solve for y. I'll just do the top one. 8x plus negative 1 equals negative 16. So this is a negative 1. I'll add it to both sides. Oh, I did it in the wrong spot. I substituted in for y instead of x. Eight x plus y equals negative 16. I'm going to add 8 to both sides. And negative 16 plus 8 is negative 8. So since I use the top equation, I'm going to use the bottom one to check. So again, this is x, this is y. So negative 3x plus y equals negative 5. That's positive 3. 3 plus negative 8 is negative 5. It sure is. So there's my answer. All right, so I have a couple options here. I can eliminate x's or I can eliminate y's. I'm thinking I'm going to go with y and multiply this top equation by negative 3. That would give me a negative 3y, which would cancel with my positive 3y. So that's 21x minus 3y is equal to 57. So I'm going to add my equations together. And this is going to give me 19x. The y's eliminate. And 57 minus 19 is 38. Divide by 19. And x is 2. Plug that x into wherever I feel like. Bottom one. Plugging that x in and solving for y. That will give me negative 4. Add 4 to both sides. And divide by 3, inverse operations. And my y is negative 5. Checking that answer, I use the bottom equation, so I'll check it in the top. So negative 7x plus y equals negative 19. Negative 14 plus negative 5 equals negative 19. Sure does. Okay, last problem. Oh gosh, what should I multiply by? Well, 2 doesn't multiply by anything to get 5, and 8 doesn't multiply by anything to get 20. So what I'm going to have to do is work with both of these equations. I'm going to multiply the top one by 5 and the bottom one by 2. That'll give me a 10 in both of these. Now, that's not the only option. I could do whatever I need to do in order to get these to cancel out. So this is going to give me a positive 10x plus 40y equals 30. Distributing that 5 everywhere to all three. Then if I distribute here, I'd get negative 10x minus 40y equals negative 30. Okay, do you see anything kind of crazy going on here? Now, this isn't going to happen every time I do this process, but in this one, everything cancels. I'd be left with 0 equals 0. And we know that that is an infinitely many solutions. If I were to be left with, say, 0 equals 5, that would be a no solution. So maybe if that looked like 10x plus 40y equals 30 and negative 10x minus 40y equals 25 or negative 25, that would actually give me 0 equals 5. And that's where I would have a no solution. But this one's infinitely many because 0 does equal 0. Everything canceled out. So on a graph, that would look like the same line right on top of each other twice. If I were to graph it in its no solution, I would see those parallel lines that never touch and never cross.